Welcome to the future.
Welcome to the Muxall Open Internet of Things video blog. I am your host, Michael Crane. In today's video, we are going to look at version 1.0 electronics design of the Muxall Active Infrared Detector, aka MAID. Just kidding. So our design is based on the open source OSEPP IR detector that we kind of reverse engineered in video 10. So the goal of designing the new Muxall IR detector has several goals, actually. The first goal is it needs to support all the original OSEPP features, which is it needs to be Arduino compatible, meaning it supports the 5-volt TTL output. It needs to have a frequency adjust pot. It needs to have a distance adjust pot. And it needs to have an indicator LED showing when it's detected events. So that's the first goal of designing the Muxall IRD infrared detector. The second goal is it needs to support the Raspberry Pi because that's what I use in my project. And I use Arduino as well, but I want it to support both. So I want it to support the Arduino and the Raspberry Pi, which means it needs to support 3.3 volts as well as the 5.0 volts, okay? Another thing that actually OSEPP supported, I don't know if they did it on purpose or not, is I wanted to support the 38 kilohertz IR receivers, and I also wanted to support the 56 kilohertz IR receivers. Yeah, it's up here at the top here. I made notes. And the reason why is for people that don't want it to be interfered with, or like a TV remote, which a lot of them are at 38 kilohertz. The 56 kilohertz is a good option. And the last goal that I wanted to accomplish, which is probably going to be the hardest, is I'd like to sell the boards for about $5, and that's assembled. All right, and that's probably going to be a little bit tough, but we'll see. Okay, so let's see where to start. So what I've got on the left here is the Muxall design, or my design. And on the right is the OSEPP schematic. Okay, it's pretty much the same. I made some changes, but let's just do an overview real quick, and I'll point out what's the same and what's different. So if you remember from the last video, this left side right here is the astable multi-vibrator, and that's what it is on mine right here. It's this is the astable multi-vibrator, okay? And it's using the two gates right here. Okay, so then let's see. So this is the infrared LED, and here's the pot. So that is right here. It's kind of in the middle on mine, all right? And then the blue LED, which is down here with its resistor, is right here on mine. Okay, and I called it blue. And I'm sorry, I didn't even think about it when I was designing this, but I should have probably numbered the resistors the same as on the OSEPP schematic, so when we're talking about it, it would be easier to talk about. But I didn't, so sorry about that. Let's see. Okay, so the pot, where's the pot? Oh, here's the pot for the infrared LED. And here's the infrared LED on mine. And here's the pot. And as you notice, I kind of moved it on the other side over here, next to the 47 ohm resistor. And so this U2A right here is down here. It's on 3A and 3B On pins 9 and 10 going to ground, it's still doing the same thing. It's just providing power to the blue LED. All right. And I eliminated this right here. I could not figure out what his purpose was. So I just took it out. Okay. And so here on the right-hand side of the OSEPP, they have the HS38B infrared receiver. On mine over here, it's the TSSP 4038, and here's the pinout for mine. Here's the pinout theirs, and as you noticed, I flipped it around backwards. Don't ask me why, but I did, and now it's wrong. So I'll have to fix that in version 2. All right. So and then so they've got a 0.15 microfarad cap to smooth out the ripples in the VCC, and I just kept the same thing, right, going right into the into our NAND gate. And this NAND gate right here is it's a TI SN74HC00DR. All right, so let's see, where are we here? Okay, so that's kind of the general overview. So, okay, so what changes have I made? You can probably tell some of them right off the bat. But I'll go over. I have a little list right here. We'll go over them. So all the components I purchased. So the TI NAND gate, the Vishay IR receiver. I forget what this guy is. He's a Worth Electronic LED. All right. And this LED, the infrared LED, is a T-Cell 6100, and it is a Vishay LED. And I'm not, they were using multi-turn pots. Where are they? Okay, so RP1 here, and oh, here it is. RP2 were just 500 ohm, like 10-turn pots, and they were through hole, and I'm like, I didn't really need that. It doesn't need to be multi-turn. So I kept them 500 ohm because the math kind of worked out. At least it did for the frequency adjust pot. It worked out so great on the dimming pot for the infrared LED, but anyway, I just use a single turn pot. They seem to work pretty good. So anyway, it's a surface mount pot. It's pretty nice. And all right, let's see here. Yeah, kept the 47 ohm, resistor. That's to limit the current going through the infrared LED, so you don't draw too much current through it. It's got 100 milliamp max draw. And so here they were syncing, if you remember from the last video, they were syncing all the current through the 74HC. And I didn't really like that too much. This thing's probably got, I think on the spec it said a max of, maybe it'll sync like 25 milliamps or something like that, or 20 milliamps. And of course, with a 47 ohm resistor and 5 volts, you're going to get, even at a 50% duty cycle, 53 milliamps. So, yeah, that didn't seem like a really good idea. So I put in a transistor switch, right? It's a NPN transistor switch to sync the current. Originally, I had set this to, this was a 10K resistor, and this was, I forget what it was, 475 or something like that. But I wanted to, kind of switch a little faster. So I just put a couple 1.5Ks in here, which gives it about 750 ohms resistance, which would give it about 7 milliamps base current at 5 volts and 4 milliamps of base current at 3.3 volts. All right. And if you remember from the previous video how this works, so here's the multi-vibrator. Here's the output right here, and it goes into U2C right here, which is on the 74HC. And basically, pin 10 right here is just tied high. So I was just kind of using it as a buffer. So I have the same thing. So we come, here's Q out, right? And I put a little Q next to it so everyone knows it's output. Follow this around, goes into pin 12 on our 74HC. I just tied the other side of this gate straight to VCC. All right, and since it's right next to each other, it was pretty simple. And but anyway, yeah. So you get a square wave through here, and this kind of just inverts it. I think it's just like a buffer. It's using it as a buffer. It comes through here, and then it just turns this NPN transistor on and off. All right, and you get a nice square wave through here, and that's how it modulates the infrared LED. Okay, so some other changes that I made is on the OSEPP drawing here. They had a where is it? It's a 100K. Oh, here it is, right here. 100K resistor, and I just put a 10K in here, and I did that because I was, like I said, I was originally going to put a 10K right here and a 10K here. I was trying to consolidate parts, so I put a 10K here. It doesn't seem to make really any kind of a difference. And it's funny, I kind of Googled around, looked in the Art of Electronics book. I couldn't really find anything on this, on how to calculate what this guy is supposed to be. Yeah, if anyone knows, let me know. I'm curious how to calculate the value for that guy. And also, I'm going to leave this 10K because I'm thinking about changing out Q1 with a MOSFET instead of an NPN transistor. And I'm going to do that basically for a couple reasons. One, the MOSFET seems to be cheaper for some bizarre reason. And I can eliminate this R6 right here. And then I'll just put another 10K right here. So then, because the MOSFET's going to have real high impedance, so I don't really need this guy, but I still want to, drain some current off the base of the MOSFET. So, okay, so what else did I change? I changed this 1K out. Originally, they had a 1K resistor for the blue LED. I made it a 475, and I did that because I think I was going to put a 475 in here, basically just consolidating parts. Actually, when we get to it, I'm probably going to make this guy a 681 in the next rev. And so I'll probably just put a 681 in there to kind of consolidate parts, right? So basically, as you can tell, it's pretty close to the same. This is probably the biggest change right there. Adding the NPN transistor in there. I just added more I added parts that would support 3.3 volts and made sure I sized everything and did some calculations to make sure it was going to work with 3.3 volts. So that's it. So I'm not going to upload this version 1 schematic because I plan on making some changes to it after we do some testing. So, and I don't want people going out and trying to manufacture this if this is not going to be the final version. But the design is going to remain pretty much the same. Just going to change some of the parts out based on the testing, and that'll be it. So, I hope you like this video. If you do, give it a big thumbs up and hit the subscribe button. That really helps. If you have any questions or comments, leave them in the comments under the video. I'll answer them the best I can, and I'll see you next time.